All right. So we're going to be talking about prototype pollution. This is going to be a long one. It's going to be pretty theoretical, and we don't have a lab just because I wasn't, I didn't have enough time to put one together for this video, but maybe at some point I'll come back to it. But yet again, the labs on Hack the Box and Burp Suite are fantastic for testing out these kind of skills. So without any further ado, let's just jump into it. What is it? Well, this is a kind of vulnerability that lets attackers add arbitrary properties to global object prototypes that can be inherited by user-defined objects. What the hell does that mean? Well, the thing is, first we're going to need some JavaScript concepts. So we're going to kind of keep this definition in our back pocket as we go through this. So first, let's just learn about JavaScript. First, what is an object? Well, JavaScript objects, which are demonstrated in this right side image, are basically collections of key value pairs known as properties. So this object user has the username, user ID, and example method properties. Each one is a key value pair. So in this case, you have key username, value Gabe, etc., etc. And these properties can be accessed with, there's like dot notation and there's bracket notation. So like if I wanted to access the Gabe property, I would use like username, or I would like call user ID, something like that. And these properties, like in this picture, can also include executable functions. This is an object literal, which just means that it was made with curly brace syntax that declares that, its properties and initial values. Now, that kind of answers part of that question. The type of vulnerability lets us add arbitrary properties, so like username, user ID, to global object prototypes. So now let's talk about prototypes. Prototypes are basically, how do I describe this? So every object in JavaScript is linked to another object of some kind, which is known as its prototype. So JavaScript automatically assigns new objects to a built-in prototype. So an example would be a string, like the username here, would be associated with the global prototype called string.prototype. So that also inherits some characteristics from the object.prototype, which is the like parent object for all of these other ones that are made beneath it. Objects automatically inherit all the properties of their assigned prototypes if they have not already been assigned their own property with the same key. So like this basically lets you reuse properties and methods of pre-existing objects. For example, like if you let people input their username and they put like space, Gabe space, it might make sense to have some kind of built-in method for the string prototype that deletes trailing spaces. Or maybe you want it to all be lowercase, so you would have like a to lowercase method. This would mean that at the very least, all of your strings that are used, regardless of what object they're in, would be able to have these methods applied to them. So it's nice from like a structural perspective, because then you don't need to implement all these things yourself. But it does kind of introduce a little bit of confusion, especially if you're new, and I'm pretty new to this, at least as far as JavaScript is concerned. So it was confusing to me trying to wrap my head around it. But that kind of answers the second part of the definition of this, which is this vulnerability allows attackers, let me just go back. Whoops. So allows attackers to add arbitrary properties, so adding like something aside from username, to a global object prototype that will be inherited by other user-defined objects. So in this case, if we are adding a property that can somehow be inherited by other user-defined properties, or user-defined objects, I think it was, yeah. So how does that work? Well, if you're looking at this fancy little chart here, we would basically need to pollute something above our object in the chain, like the string.prototype, or most of the time our target's going to be this object.prototype. So that's the one we're going to be aiming for every time. And what this might look like, well, I mean, you kind of have an idea of what it looks like. If we can write into this, because of the properties of inheritance, that will mean that other objects that are made that inherit any of these will also inherit whatever property we can inject into this parent prototype. So kind of a lot of words all together there. And we'll go to kind of an analogy that might conceptualize it. But before we do that, let's talk about how like accessing and modifying a prototype works, because there's pretty good reasons you might want to, modify a prototype. So chaining references is basically like this syntax right here. So if I made like that object we saw on the last slide, If I wanted to access the string.prototype, I would just use one of these. I could use 2 to go back 2 layers in that inheritance chain. And then 3, obviously, well, there's nothing 3 high, so that's not going to work. So you have to get the number right. But if you wanted to, you might think, well, why would I want to modify a prototype? Well, let's say that, that example I had earlier where it's like you want to remove trailing white space. Before this was a built-in function for the string.prototype, a lot of developers would just implement this themselves by adding, the string.prototype.remove white space. So they would add a new property, remove white space, to this prototype, and it would just remove trailing white space so that they could use it on all of their strings. Makes sense, perfectly good reason to have it, and because of the properties of inheritance that we've already gone over, especially with that picture, it's really useful, and you just need to edit a couple lines, maybe implement just one function, and you're good to go. So, that's why it's there. But the big thing is, why is this vulnerable, or how does this, where does a problem come in? And this vulnerabilities will arise when a JavaScript function will recursively merge an existing user-defined object with some other object. And if one of those objects contains user controllable properties and it doesn't sanitize the key, which the key in this case is _proto, if that key isn't being sanitized, that's where you'll run into issues. Now, that's kind of a headache of an explanation. So I have come up with an analogy that is sort of helpful, or at least it was helpful to me. So I'll share part of it here. And I even have some JavaScript on my website that you can go ahead and look at that will maybe, bridge the gap between the technical implementation and this analogy. But it was helpful for me, so I'm going to repeat it back. So think of a recipe book where the beginning of this cookbook, right, has a, some kind of guide that gives you basic understandings, or it has default stuff. So maybe the beginning of this cookbook will say here's how long you're supposed to bake, this kind of meat, or here's how long you're supposed to, or, here's the definition of simmering, or here's how to properly season something, whatever. And then other recipes later on in that book can inherit those instructions. So maybe you have a recipe how to cook, I don't know, a fried rice, and it's simmer this ingredient for this long. And you're thinking, okay, well, what's simmering? You would go back and look at that master section of the book, and it would tell you. So recipes can inherit those things. The thing that an attacker could do, or us, we can scribble in details in the margins of the master cookbook and edit these ingredients or measurements. Or maybe, our object, let's say we have a recipe that we're reading from that we control to some extent. And we cross out, the definition of simmering, or, maybe we add a new definition of simmering. And then somebody else comes along and they want to add a new recipe to the book, and they see, oh, okay, well, let me just look at, this other recipe that we edited, and it has this new definition of simmering, and it says, oh, okay, well, I'm going to merge these two as we make this, second edition of a recipe or something. And upon that merging process, we have made it so that that's now overriding the instructions that are in the master cookbook. Right now, it's inheriting this new definition of simmering. And that's, basically, what this is, right? You're merging the objects together and and because there's no sanitization, right? You're merging these user controllable objects together, and those properties that we're implementing are being inherited. And so, that's kind of the example I go for. And, if we can pollute the prototype, that object.prototype, some way with a harmful value that's used in a dangerous way, even though we can pollute anything, obviously object.prototype, the most parent prototype is going to be the easiest one to go after because everything else inherits from that one. In order to exploit this, that by itself doesn't do anything, right? We need more. So first we need to find an input that lets us pollute, that object.prototype with some kind of arbitrary property. Then we need a sink. So a JavaScript function or a DOM element that lets us execute some kind of binary or some kind of arbitrary code. And then we need an exploitable gadget. So we need, a property that's passed into one of those JavaScript functions or DOM elements that isn't being properly filtered or sanitized. So we need a source and a sink, and the sink needs to, pass in something that we can control with our prototype pollution in the form of a gadget. So let's talk about what that might look like. So there's different places you might be able to, your input might determine or might change around what happens. So in this case, like you might see pollution sources in the URL. So if we call the parent prototype here and implement like our evil property, if this merge operation comes true, then we'll kind of see, this like our target object will then its parent property will be, or its parent prototype will then have this evil property, and then whatever our payload is will be executed whenever a new object is created. JSON input is kind of the same. It's just another way. JSON input, web messages, these are all ways that you could be passing input to an object that we could be trying to pollute. So it's just really trying to create or this property here that's being added to the parent prototype. In this case, like let's say there's like the JSON.parse method is being used. The JSON.parse method treats JSON objects as strings, which can be a potential vector for prototype pollution. So if like this JSON right here is being injected via a web message, the object might be converted into kind of, so like you'll see object literal, prototype, evil property payload, and then JSON parse, proto, evil property payload. In this case, the object literal won't actually get inherited. It won't have this proto property here, but in this case, JSON parse will, because it treats each of these objects as an arbitrary string, or it treats its own objects as arbitrary strings. So if this object gets merged into an existing object, then, we just added a new property, which is good for us because that's the first step. The next step is like finding sinks, which I think we'll talk about up here. But first, I do want to show you some screenshots of the DOM invader. This comes with Burp Suite, and it's super easy to use for the most part. It doesn't find everything, but it does make your job a lot easier because it's pretty tough to find these things manually, in my opinion. You can configure it in a handful of ways, but in this case, like it looks like it found something. It found a source for us to look at, which was this website had a search bar. So in this case, it was able to inject a property there. And then to verify that this is what was going on, we could see like in the inspect element DOM invader tab here, you can see that it added a test property. And then when we created a new object and then looked at the test property, you could see that it was inherited. So we were able to successfully pollute the, the object.prototype. So that's what the DOM invader will try to do. If you can't do that, then, or if the DOM invader doesn't find it, you'll be able to, do it kind of yourself in the same way that we, from a high level talked about a second ago. The next thing we can kind of go over, given this is like all client side so far, is finding these sources and gadgets. So what we kind of walk through is you'll want to inject a property and then see if it's added when you create a new object. Once you verify that that works, then you want to look for some kind of gadget. So once you found a source that lets you add some kind of parameter to the global object.prototype object, you want to look through the source code and find properties that are used by the application or like libraries that it imports. And then you want to add a debugger statement to the beginning of that script that will basically make it so that when the target script is loaded, the like debugger for your browser should pause the execution of that script. And if you can get it to generate a stack trace for when the gadget runs, you might be able to determine if that property is being passed into a sink like inner HTML or eval. And, if you find it's being passed to a sink without some kind of proper sanitization, then you can basically just move on to the next step, which is, using like a, trying to trigger some JavaScript to get run. There's other ways that you can pollute. So if the like _proto thing is being sanitized, you might be able to use the constructor. The way the constructor works is, like if you use the constructor to, how do I describe it? So unless the prototype is set to null, every JavaScript object has a constructor, which is a reference to the function that created it. So if we weren't allowed to call prototype, if I created an object and called the constructor.prototype, it would call object.prototype because that was the, it's a reference to the function that created this object. So if we make an object and then call it using the constructor, it'll call the, whatever the parent is. Another example would be like if there's, this key double underscore proto double underscore is being sanitized improperly. So in this case, it's taking constructor double underscore proto or the word prototype, and it's just replacing it with nothing. We could just use like a payload like this so that it cuts out this middle part, inserts nothing in between, and then, the double underscore proto key is still there. It just wasn't properly sanitized. So that's another example of like a quirk that you might be able to find when you're trying to get this initial object to be, or this initial property to be modified. There's also, you could find pollution in browser APIs. One example would be like the fetch API. It's a really easy way for you to trigger an HTTP request. It takes two arguments. The first argument is the URL, and the second is the options object that lets you control other parts of the request. So you can see the URL, which is where you're sending the request, and then the options object here has the method. So these are just the different, parts of the request, the method, the body. And for example, if this isn't, if the headers, for example, property isn't being defined in this initial scope, then, we might be able to pollute object prototype with our own headers property. And then that would change how this fetch, API works. It would then, send it with our header, or, we could change like the status to always pull like a 401 or something. Who knows? It just depends. But you could use this in certain contexts to execute cross-site scripting, depending on what gadget and what like sink and source is being used. Another example would be like a object.define property. So some developers might try to block prototype pollution by using this method. And it lets you set like a non-configurable, non-writable property that's only called directly. So, configurable and writable are both false. The first argument is this vulnerable object, and the second argument here is this like gadget property, and the third is this larger object. But of course, like if certain things aren't set, so how do I describe it? So this approach doesn't really work because it accepts an options, this like options object here that has the configurable and writable properties. And this is usually like it sets an initial value for these properties that are being defined. But because this property is like, because this like object.define property is often being used as a countermeasure, developers typically or sometimes will forget to set these values. So if we can just change like these properties of like writable and configurable to true or false if they're not already set, then we might be able to just pass stuff to object.define property anyway. Now client side stuff is cool, but it's nice because at the very least you can get JavaScript to execute. And if you can do it all through the URL, then you could serve that to victims pretty easy. But what if that's not the case? There's also server-side prototype pollution. So this is like, JavaScript was designed to be a client-side language that runs in your browser, but there's server-side runtimes like Node.js, and that means that JavaScript is often used to build servers and like other backend applications, and those are also going to be vulnerable too. The issue is that they're kind of hard to detect, right? If it's not running in our browser, we can't actually like debug that JavaScript. We can't see the source, and it'll be pretty tough to find vulnerabilities. We don't have access to source code or dev tools, and if we break the application, it might just be broken. Like, if we make a change that breaks it in client side, it's no big deal. We just refresh the page. But if we break something server side, like that's broken. So really difficult to do some ethical stuff with this if you're testing, or really difficult to troubleshoot that with a service team. So be super careful when you're testing this. There's two types of like ways we can do this. One is reflection, and I find that honestly like more complicated than detecting it without reflection. And so if you're not seeing your inputs, like if you're not able to see properties being reflected back to you, then you'll want to make sure that you're doing these kind of blind-ish tests that won't cause harm to the application. The first one is if we can override the status code. And what that would look like is you might submit a request where one of your properties for your JSON object is like the status. And if you then, trigger an error and it changes the status code, you would know that that works. The other example would be if you're submitting JSON input to an API or a web application, and you set the JSON spaces, like by using, in this case, they're using constructor and prototype JSON spaces. If we change this to 10 in the response, the number of spaces in the JSON that's there might change. And that would be a way to verify that our pollution worked, at least for that property that we know nothing about. The other one would be like the character set. So you could first, add an arbitrary UTF-7 encoded string to a property that gets reflected in the response. And then you could try to change the content type property to be equal to UTF-7 and then see if it gets decoded correctly in the next response. So these are all like non-harmful ways of checking to see if you can, manipulate the application's behavior on server side. And then once you do that, the process is basically the same. Look for a source if you can. In this case, like these are your sources. Look for an exploitable gadget and then see if it gets passed to a sink. Now, the thing is, for client side, you would want to pass it to a sink. For server side, typically you'll actually see more like remote code execution, which kind of sounds weird, but it makes a bit of sense because of just like Node.js and Express.js like frameworks. So like one example is like one of the command injection sinks in Node.js would be like the child_process module. And it contains just a lot of like really, interesting functions. So like, we'll talk first about, like the node_options environment variable. It lets you set a string of command line arguments that are used when a node process starts. And there's also like the shell property that lets you set a specific shell to use when running commands. Now, if we can pollute the node options property, we could probably trigger an interaction with our collaborator like this. So if we set the shell to be node, and the node options property to point to some domain that we control, then we would basically be able to, verify not only that this works, but we're executing code, right? We're triggering web requests here. And if you have like child process.fork is kind of similar, where it uses the like exec argv property, which is just an array of strings, but you could include an array of different strings that basically spawn a child process, so you could perform remote code execution. And the same goes for like child process exec sync. The method accepts the options object as an input that you could then potentially pollute. And if you can pollute the shell and like input properties, then you could basically just execute some kind of command. You do need to work around a lot of like weird syntax stuff with that, but there's plenty of like resources online to like find examples of things that work in default node configurations anyway. So those are the examples that we've got to go through. And as far as prevention goes, like it's kind of straightforward once you understand all this stuff, but basically make sure that, you sanitize keys like _proto, in like a robust way, or just, use an allow list of keys if you're able to in your environment. You also want to prevent changes to prototype objects. One approach to this that's pretty common and works pretty well is using the object.freeze method on an object. So that makes sure that its properties and values can no longer be modified. No properties can be added. It's really straightforward, simple to use. Obviously, there's other workarounds, but that's a popular one. And last is you want to make sure that you're preventing inheritance where it's not required. So when you define like an options object, use like a map instead. So maps still inherit, they can still inherit malicious properties, but they have a built-in get method that only returns properties that are directly defined on that map itself. So if you stop somebody from defining things on the map, then you can basically control what's being inherited by your objects. That's all we've got for today. This is going to be probably the last video in this kind of applied review series. So, next for me is take the Burp Suite Certified Practitioner exam. Hope I pass. And then I'll probably come back with a review for that. And yeah, but that's all we've got so far. I'll catch you in the next one. Bye.